Not all quadratic formulas or quadratic equations in the form ax squared plus bx plus c equals 0 can be solved by graphing or factoring. Sometimes we need an equation that's going to help us find the irrational solutions to a quadratic equation. To do that, we're going to use something called the quadratic formula. This is the quadratic formula where a, b, and c are gotten from the equation ax squared plus bx plus c equals 0. Well, we've already discussed how you determine what a, b, and c are, because a and b were quantities that we used to find the axis of symmetry, and c is the y-intercept. You have to be careful, though, when using this formula, and remember, whenever you plug numbers into an equation, the numbers must be in parentheses. Let's solve the equation 2x squared minus x equals 4. First of all, in order to use the quadratic formula, you need the equation to be equal to 0, and right now it's not. To make this equation equal to 0, you have to move 4 over to the left-hand side of the equal sign. To do that, you have to change 4 to its opposite, which is negative 4. So the equation we're going to solve is 2x squared minus x minus 4 equals 0. Let's now determine what a, b, and c are. A is 2, b is negative 1, and c is negative 4. One of the reasons students tend to get the solutions to a quadratic equation wrong when they're using the quadratic formula is because they miss the signs, like the negatives. After you identify a, b, and c, the next thing you're going to do is plug those numbers into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We're going to simplify this in parts. So the way that I would recommend doing it is to start by evaluating the part that's under the square root sign. You can type that into your calculator verbatim, hit enter, and you'll get an answer out. You should get 33. So now x is equal to, 2 negatives make a positive, plus or minus the square root of 33 all over 2 times 2 is 4. The plus or minus symbol actually means that there are two solutions to this problem. The two solutions are x equals 1 plus the square root of 33 divided by 4, and the other solution is x equals 1 minus the square root of 33 over 4. Now when you type this in your calculator in order to evaluate the decimal values, I would really recommend that you first evaluate the numerator. So 1 plus the square root of 33 is about 6.74. And then you can divide. 6.74 divided by 4 is about 1.67. In the second solution, do 1 minus the square root of 33 first, and you should get negative 4.74. Then divide it by 4, and you should get approximately negative 1.19. How do you know if you did this problem correctly? Well, if you graph the original quadratic equation, you should see that one of the solutions is between 1 and 2, and the other one is between negative 1 and negative 2. And you'll know you probably have done it correctly. Now, this particular problem, you need to use the quadratic formula, because the solutions are irrational numbers. Irrational numbers are non-repeating, non-terminating decimals. We truncated these. We rounded them off. The quadratic formula can also be used for problems that you really don't need it for. This problem is a perfect square trinomial that we've run across many times. This is the one where the two numbers that multiply to give you 9 but add to give you 6 are 3 and 3. So if you factor it, and then you use the zero product property, you can solve and find out that the solution is -3. There are two solutions, they're just both the same value. If you are to graph this, you'll see the graph hits the x-axis at -3. And then that's it. That's where the vertex lies. So it only touches the x-axis one time. But in order to use the quadratic formula, you would first tell me that a is 1, b is 6, and c is 9. So when we go plug this in the quadratic formula, I get x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Remember I said that the best way to simplify this problem is to start by simplifying what's under the square root sign. Well, 6 squared minus 4 times 1 times 9 is 0. So you get -6 plus or minus the square root of 0 all over 2. What's the square root of 0? It's just 0. And what happens when you add or subtract 0 from anything? Nothing. It turns out the solution is just -6 over 2, which is -3, which I found out earlier by factoring or graphing. But at least this is a simplistic problem to help you understand the procedure of going through the quadratic formula. Let's do an application problem. Your school's jazz band is selling CDs as a fundraiser. The total profit P depends on the amount X that your band charges for each CD. The equation, P equals -x squared plus 48x minus 300, models the profit of the fundraiser. What is the least amount in dollars you can charge for a CD to make a profit of $200? Well, the first thing that I'm going to do is I'm going to replace P with 200 in this quadratic equation. So we want to solve this quadratic equation for X to find out how much we could charge, or what the least amount we could charge is, and still make my $200. In order to solve a quadratic equation, the equation must equal 0, and right now it does not. So first you're going to make it equal 0. And the fastest way to do that is to subtract 200. So now I have the equation -x squared plus 48x minus 500 equals 0. After you have an equation that's equal to 0, you're going to determine a, b, and c. And then we're going to plug it into the quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alright, now let's go back to the part where I said we want to solve this in parts. So evaluate the part that's under the square root sign. You should get 304. So -48 plus or minus the square root of 304 over -2. Remember that the plus or minus sign means that there are two solutions. One of the solutions is x equals -48 plus the square root of 304 over -2. And the other one is x equals -48 minus the square root of 304 over -2. So I'm going to start by evaluating the numerator. In my calculator, I type in -48 plus the square root of 304, and I get negative 30.56. I'm going to divide that by negative 2, and I find out that it's about $15.28. Now let's go to the second solution. I'm going to do negative 48 minus the square root of 304, and I'm going to get negative 65.44. I'm going to divide that by negative 2, and I'm going to find out it's 32.72. The reason I rounded everything to the hundredth place is because we're talking about money. Now, the original problem asked what the least amount in dollars we can charge for each CD and make a profit of $200. Well, clearly the least amount we can charge is $15.28 a CD, because we're looking for the smaller of the two answers. Besides the fact, if you think about it, would you want to buy a CD for $32.72? Probably not. So the lower the cost, the more likely you are to sell more product.